So when you first start SAM, this is what you see. This is the welcome window. Our little notification area is broken at the moment. We're having server issues, but you can see the notifications by clicking the Here link. And so there's the announcement of today's webinar and all the other notifications from previous times. So let's see, I'm going to create a linear Fresnel case. So I'll just type a name for the case in this text box here, create a new file. So linear Fresnel is a concentrating solar power technology. We've got a list of all the technologies in SAM here. I'm going to choose linear Fresnel. Once I choose a technology, on the left side of the technology and market window, SAM displays the financing options that are available for that technology. So for linear Fresnel, we have commercial and commercial PPA, and then the various utility financing options. I'm going to just go with the utility IPP option for this example. So linear Fresnel, utility IPP. And this is the case that I've created for the linear Fresnel case. SAM creates the case in the SAM file. A case in a SAM file is analogous to a worksheet in an Excel workbook. So I can create more than one case. For example, if I wanted to compare this linear Fresnel system with a PV system, then I'd go to the case menu, click Create Case, and then create my PV system. Give it a name, click OK, and now I have two cases, two tabs. Here's my linear Fresnel system, and here's my PV system, and I can compare the two by switching between the tabs. So I'm not doing a comparison here, I'm just demonstrating linear Fresnel, so I'll delete my PV case. To delete the case, you just click the X on the tab here, and that removes the case from the file. So the linear Fresnel model is for a direct steam generation plant, they're called DSG plants, that produces superheated steam to drive a conventional power cycle. The first set of input pages here, so the navigation menu here has buttons that you click to display input pages. So these are the financial model input pages, which I'll skip over because I'm just going to talk about the performance model. The costs for the linear Fresnel system are here, and you can see that we've got costs in various units. So we've got costs in area of aperture area, solar field aperture area, $ per square meter, dollars per kilowatt of power cycle nameplate capacity, and then various fixed costs as well. And then you've got O&M costs down here. Again, these costs are just rough numbers that we've made up to kind of help you get started. You need to do a little research to populate these numbers with better values. And then the technical inputs for the linear Fresnel model are in these pages here. So let's start with the solar field. Let's see, I've got my resolution set pretty low for this presentation, so I can scroll here to show the whole page. So this is where you specify the properties of the solar field. I won't go into much detail here. I will just mention that the linear Fresnel model allows you to model two configurations for the solar field, either a recirculated boiler or a once-through boiler. As with the other CSP models, you can either specify the field area using the solar multiple, or option 2 is to specify the field area explicitly in square meters. So the solar multiple, the definition of solar multiple is that a solar multiple of 1 is equivalent to the solar field area required to drive the power block at its design conditions. So it's an input that's used often for CSP modeling. You can read more about the solar multiple in the help system. There's the definition and some suggestions for sizing the solar field are in help. So the collector and receiver page is where you specify the properties of the collector and of the receiver. And you've got a couple of options. To specify the boiler geometry, you choose boiler geometry, and then you can switch it over to superheater geometry to specify the superheater geometry. And again, when you're using the model, you can get details about how this all works in help. The linear Fresnel model, the field provides heat to drive a steam Rankine power cycle, which can have either evaporative, air-cooled, or hybrid cooling. And then there's an optional backup boiler. You can, if you want to model a system with fossil backup. A quick note: you can use the linear Fresnel model in SAM to model a compact linear Fresnel reflector, the CLFR technology. You just need to adjust the heat loss equation coefficients for the receiver to do so on the receiver page. You need to adjust these coefficients to model a CLFR system. So once you've specified your inputs, you click Run, the green arrow, and then you get your metrics table here. This is the total annual energy produced by the system. It's 235 million kilowatt hours for this 100 megawatt linear Fresnel system in Blythe, California. This particular project requires 12.65 cents per kilowatt hour to meet the target internal rate of return that we specified on the financing page. We can look at the monthly output of the system here. So all this stuff is the same as the other models in SAM. You can look at the cash flow detail and so on. So that's my very quick, and I realize insufficient, introduction to linear Fresnel, but just want to make you all aware that that is available in the new version of SAM.